and welcome to Algebra 2. We're going to start off our first chapter with a little bit of a review of Algebra 1. In the first lesson, we're going to review some linear equations, slope-intercept form, x and y intercepts, and point-slope form. We'll move into factoring, quadratic equations, and then some exponents. So let's get started with our first lesson. Most of us think about slope and we think about the equation y equals mx plus b, which is really slope-intercept form. However, we're really just talking about slope, and slope is designated by the letter m. So we need to remember back from our Algebra 1 days in 8th grade that slope is designated by the letter m. So slope, most of us remember that slope is rise over run, up and over when we're looking at a graph. Slope is also, as a formula, the change in the y's, y2 minus y1 over the change in the x's, x2 minus x1. We can also designate that as the change in the y over the change in the x, where the delta represents the change, and the triangle is delta, or in words, the change in the y coordinates over the change in the x coordinates. All of that review from Algebra 1. So let's get started with finding some slopes. Another name for slope is the average rate of change. AROC for average rate of change. If we want to find the average rate of change or the slope between 2 points, such as -1, 6 and 3, -10, let's first talk about those points. Those are called an ordered pair. And remember, all ordered pairs are designated as x comma y. So if we have two ordered pairs, we need to designate them as individual points. So I'm going to call the first one point 1. So this as an ordered pair is going to be x comma y, but so that I know that it's point 1, we're going to put subscripts in there. So x1, y1. 3, -10 is going to then be point 2. So we're going to designate this one as, again, an ordered pair x comma y, but we'll use a subscript of 2 to designate that as point 2. We can then substitute in to find the slope into my formula for slope, y2 minus y1 over x2 minus x1, and substitute in the values into your formula. So the value for y1 is -10, -10 minus -6, divided by the change in the x's, 3 minus -1. And notice when we substitute in -1, it's a negative number, so it should go in parentheses. And now we're going to simplify our numerator. -10 minus -6 is -16. Our denominator, 3 minus -1, and minus the negative makes a plus, so 3 plus 1 is 4. And now we simplify -16 over 4, and that would be -4. And we might remember back from 8th grade, if we watched the slope dude video, that when we're talking about slopes of lines, all slopes of negative lines from puff positive, this is nice negative, so the slope of a negative line is going downhill. So these are negative slopes. If we had a slope of a positive line, puff positive, all positive lines, slopes will go uphill lines. So let's take a look at, if we have that graph, how can we find the slope of that line? So here we start off with a line, and we want to find the average rate of change, or the slope for that line. So the first thing that we need to do is identify where 2 points are on that line. So we find 2 points on that line. Do not choose those points that do not cross over intersections. Okay? To only find those good points. So now we identify them. We can call each point, if we would like, as we had done in the previous example, we can call this one x1, y1, and x2, y2. And we can apply the formula y2 minus y1 over x2 minus x1, and we can find our slope substituting into our formula. However, there is another way. We can use that concept for slope as rise over run. And most of us, probably given a graph, would choose this formula. So when we did rise over run, that was just counting off, going in a horizontal and a vertical fashion. So most of us remember we draw in the rise, we draw in the run, and we count them off. So I'm going to rise 1, 2, 3, 4 blocks. I'm going to run 1, 2, 3. So I have a rise of 4 and a run of 3, slope of 4/3, the same thing we got if we used the formula. However, there was no correct answer which point you had to begin with when I did a slope. So if I started with my point 3, 2 as my first point, and I would rise over run. So here, in this case, my rise was 1, 2, 3, 4. I went down 4, so that would be a -4. My run is 1, 2, 3. I went to the left 3, so that was -3. So in this case, my rise is -4. My run is -3. So negative over negative would make that a positive 4/3. And notice that is the same slope you got in any way, shape, or form. So here, this was an uphill line, puff, puff, positive. So increasing slope, or increasing line, positive slope. So slope of 4/3. So those are the two main ways that we are going to find the slope, either using the formula y2 minus y1 over x2 minus x1, or you can count off rise over run. In the next two examples, you're given 2 points, identify the slopes. Again, if you are more comfortable, feel free to identify your points as x1, y1, x2, y2, substitute into the formula for slope, 10 minus -6 over 2 minus 2. That gives me 4 over 0, and 4 divided by 0. Well, that's kind of interesting, because if I take 4 and I divide it by 0 and I put that into the calculator, it is going to give me an error message, meaning my slope is undefined. So let's think about that in terms of slope. If I'm going to rise 4 units, but don't run, that tells me my line would have been a vertical line. So slopes of vertical lines were undefined. In example number 4, the rate of change between the points 2, 6 and the point 10, 6. So again, we can identify my points x1, y1, x2, y2. So y6 minus 6 over 10 minus 8. 6 minus 6 is 0. Over 10 minus 8, or 10 minus 2, 8. And 0 divided by 8, if I have 0 and I divide it by 8, that gives me 0. So if I think about that, I'm going to rise 0. I don't rise, but I run 8. I'm going 8 to the right. I can see the slope is a horizontal line. So here my slope is horizontal. Horizontal lines have a slope of 0. My undefined lines are lines that are going to be vertical. So the difference between those two special cases that you talked about in 8th grade. Okay. Let's flip over to the next page and try some examples that are not worked out for you. Okay. So identify the slope between the point 0, 2 and 6, 3. So let's identify my points. If it is helpful, write your ordered pairs above, x1, y1, x2, y2. Substitute into the formula for slope. Y2 is 3 minus y1 of 2, x2 of 6 minus x1 of 0. Let's simplify. 3 minus 2 is 1. 6 minus 0 is 6. Slope of 1, 6. So positive, so puff, puff, positive, the uphill if I were graphing this. Now would be a good time to pause your video and do the next two. Okay, welcome back. Okay, and let's take a look at your answers. For the middle one, 3 minus 3 over 4 minus -2. Again, when I substitute in the negative numbers, if you put it in parentheses, end up with 0 over -2, so slope is 0. And the third one, we ended up with a slope of 4 over 0. Can't divide by 0, gives you an error message, so the slope is undefined. And yes, you must write out the word undefined. Okay, let's take a look at the bottom one. Number 4, find the average rate of change or the slope given a diagram. So again, to review, let's identify 2 points on the graph that the graph easily goes through. So pick out your 2 points, maybe those two. Identify your slope as rise over run. So I'm going to go up 2, 1, 2, 3. I'm going to go over 3. So slope is 2/3. Again, now would be a good time to pause your video and try the next 3. Look at number 5. If you have a slope of -3, so let's see, identify 2 points, count off rise over run. So this is nice negative going downhill, so a slope that should be negative. If I would have chosen the 2 closest points, then I could have identified down 3 over 1, and my rise over run would have been a fraction that I would not have needed to simplify. Number 6, slope of 0, because it is a horizontal line. However, I wasn't sure. I could have identified 2 points and counted off no rise, and in this case, a run of 2, and 0 divided by 2 would simplify to 0. And number 7, identify 2 points. In this case, I have a rise of 3, a run of 0, and 3 divided by 0 is 0. Okay, awesome. That concludes today's lesson, and we should now be able to move into your assignment.